Okay, for this video, I'll be going through Pure Physics Dynamics 2, Tutorial 2. Okay, question 1. Which property of a body resists any change in its state of rest or state of uniform motion? Okay, the answer is inertial. And you might want to take note that the larger as mass increase, inertia will increase. Okay, so what is inertia? Inertia is actually the reluctance of a body okay, to resist any change in its state of rest or state of uniform motion. So that is the definition for inertia. Question 2, a coin is placed on a cart that is on top of a beaker. If the cart is pulled away quickly, the coin does not move sideways but fall into the beaker instead. This is again due to inertia, right? So originally it is at rest, right? And actually it is being pulled down by gravitational force, but the cart actually exerts a upward normal force to support it. That's why it does not fall into the beaker. Okay, however, when we pull the cart very quickly to the left or right, okay, then the original motion or non-motion of the coin is that it doesn't move. But without the support of the cart, it will actually fall down. Okay, because then there will be a resultant force. Now, which property of the coin makes this possible? So again, it is the inertial or the mass. Okay, so answer is B. Now, astronaut in space wants to compare the mass of two balls. He holds a ball in each hand and moves them up and down slightly for a few times. What is the reason for doing so? Answer is A. He's comparing the inertial or actually the mass of the two balls. Okay, the ball with more mass will be more difficult to move or stop. Okay, because now it is in space, and maybe if he's in moon, right? Example, the moon's gravitational field strength is lower, so both balls will be affected by this gravitational field strength, the decrease in the gravitational field strength from Earth to moon. Okay, but however, since both are subjected to the same gravitational field strength, he can actually test for himself which one has more mass. Okay. Now, velocity of a mass increases uniformly, so velocity increase. Okay. Therefore, there is acceleration, and because it increases uniformly, so it is a constant acceleration. Okay. So this happens when the resultant force acting on it is, okay, so we use this formula, F net equals to ma, right? The mass is constant, of course. The mass doesn't change. The acceleration is constant because the velocity increases uniformly. Therefore, the F net will be a constant. So answer is B. Okay, so the explanation is here. Velocity of mass increases uniformly with time, means there's constant acceleration. You must be able to link this, and then with the formula, then you can find out that the F net must be constant. Okay, Newton's third law identify pairs of forces, right? Third law is A on B. Okay, then equal and opposite will be B on A. Now, state two ways in which the forces in a pair are identical. This one you can actually find it in notes or textbook. Okay, they have the same magnitude. They are the same type of force. So state two ways in which the forces in a pair differ. Okay, they act in opposite direction, and they act on opposite body or different bodies. Now, part C, one of the forces acting on a car can be described as follows. The Earth exerts a downward gravitational force of 12,000 Newton on the car. So this is the car, and this is Earth. The force of Earth on car, right? Earth on car, FEC, will be equals to the force of car on Earth. Okay, but take note, they need to be in opposite direction. They need to be in equal magnitude, and they need to be the same kind of forces. So basically, you need to know these two. Okay. So the car exerts an upward gravitational force of 12,000 Newton on the Earth. They act on opposite body. Okay, so very important for third law. Okay, they must act on opposite body. Okay, so A acts on B, B acts on A. And this kind of question is a very kind of popular question. Okay, a book weighing 40 Newton rests on the table. State two pairs of action-reaction forces involved, in each case stating the magnitude, direction, on which body the force is exerted on and exerted by which body. Okay, so let's look at the answer. The book exerts a downward normal force of 40 Newton on the table. Okay, so this one I can call it F, book on table. Okay, so the table exerts an upward normal force of 40 newtons on the book, so they must be equal in magnitude, so it must be table on book. Okay, so this is for the first pair. Now, second pair, the earth exerts a gravitational force of 40 newton on the book towards the center of earth. Okay, so this is F, earth on book. Okay, and since third law, the forces must be equal but act on opposite body, then it must be F, book on earth, and it is also equals to 40 newton. Similarly, this is also equal to 40 newton. Okay. Okay, question 7. Photograph shows a toy car driven by air from a deflating balloon. When the air in the inflated balloon is released, the car starts to move forward. Use Newton's first and third law of motion to explain the motion. Okay, so from Newton's third law, the backward force on air by car is equal to the forward force on car by air. So we are using Newton's third law, so they must act on opposite body, okay, which is force of car on air must be equals to force of air on car. Okay. Okay, then on Newton's first law, why is there a resultant force? The car, since there's a resultant force, the car will not continue in its state of rest, but it accelerates in the direction of the resultant force. So actually, first law and second law are pretty simple. Let's do a quick recap. Newton's first law is that, okay, when there's no F net, no resultant force, the object will either be stationary, not moving, or move with constant velocity. Okay, so this is Newton's first law, law of no F net. Newton's second law is law of F net. That means there must be F net. And very simple, if there's F net equals to ma. Since all physical objects have mass, therefore there will be acceleration. Okay, that means with acceleration, it cannot move with constant velocity. So first law and second law, they are mutually exclusive. That means they cannot exist together. Okay, question 8, some kind of calculation. A horizontal force of 20 Newton is applied to an object with a mass of 5 kg. So with all calculation question, I will need you all to actually underline the numbers. But not just underlining the numbers, you also need to know what are all this. So obviously this is a force, a horizontal force with a mass. So mass is represented by the letter m. So I can write m equals to k, 5 kg. Now calculate the acceleration. So acceleration has a letter a, right? So with this, you can then apply into the formula. But part A says if it's on a smooth horizontal surface, we can take it that there's no frictional force. If it's smooth, okay, we take it that there's no frictional force, and we will need to draw the free body diagram. Okay, so you can just use a block to denote the object with mass of 5 kg, and there's a force of 20 Newton. Okay, and since there is no other horizontal forces because there's no friction, therefore this F net is actually your F of 20 Newton. Then you apply the formula, you should get 4 meter per second square. Now if it's on a rough horizontal surface and there's a constant frictional force of 5 Newton, so again represent it using a free body diagram. Okay, but now we have frictional force, so the F net will then be the larger force minus the smaller force. So it's 20 Newton minus 5 Newton, we get 15 Newton. And again, you apply your F net equals to ma, you should get 3 meter per second square. Okay, so always draw your free body diagram, always identify what are the numbers, what values are given. Okay, a man applies a horizontal force of 150 newtons, so I know this is F. Is it F net? We don't know yet. With a on a box with a mass of 20 kg, so the M is 20 kg. Okay, so if they say mass, you try to use the letters or symbols to represent it so that it can be applied into the formula. So it's across a flat ground. As a result, the box moves at a constant velocity of 0.4. Whenever you see constant velocity, you must what must come to your mind? You must think of acceleration is 0. If acceleration is 0, that means your F net is 0. Okay, because F net equals ma. So this is a very important sentence. Okay, if you see anything moving with a constant velocity, therefore acceleration is 0, so your F net equals to 0. So determine the resultant force. So we have gotten the answer already, because we know constant velocity, acceleration is 0, F net is also 0. Okay, so do you need to write Newton's first law? You don't need to. Okay, so this is just a 1-mark question. Now the frictional force on the box. So you draw your free body diagram. So I'll just make use of this. The man actually exerts a force of 150 Newton. So by right, if I push something, there could be acceleration. But now there is no acceleration, because the question tells me that it moves with constant velocity, which means acceleration is 0. That means your F net equals to 0. Therefore, the frictional force must be 150 Newton. It is equal and opposite, so that it cancels out, and therefore your F net becomes 0. Okay. Subsequently, the man applied more force, causing it to accelerate at 2.5 meters per second square. Whenever there's acceleration, okay, there must be F net. Okay, so now given acceleration is the value of 2.5, so you put A equals to 2.5 meter per second square, and because you know the mass is 20 kg, you can actually use this to find the F net is equals to 50 Newton. Okay, so now the F net is 50 Newton. How would I represent the F net? The man pushes, this is the force by man on the box, and this is the frictional force. Okay, now I know that there is a F net of 50 Newton. I always represent it with a double arrow and above the object or not touching the object. So this is 50 Newton. Now in order, so this is for me to visualize. In order for the force of man to exceed frictional force by 50 Newton, and I know frictional force is 50 Newton, right? The frictional force is 150 Newton, right? And in order for this system, the force system to have 50 Newton, the force of man on the box must then be 200 Newton, right? So with 200, you subtract away the frictional force, you should get 50 Newton. And when you have 50 Newton as your F net, then we can work backwards. We should get our acceleration to become 2.5 meter per second square. Okay, so this is how you can check your answer. So free body diagram, very important. It can help you to visualize the forces acting on the body. Okay, question 10, a bullet with a mass of 10 grams. Okay, by the way, I think I didn't mention this. F net equals to MA, or your W equals to mg. They are SI unit formula. That means everything must be in SI unit. So this is a common trick by the teachers, a mass of 10 grams. So I'll put here mass equals to 10 divided by 1000. Why divide by 1000? I'm trying to get the mass in kg. Okay, because I know this is a SI unit formula. It travels horizontally at 100 meters per second. So this is the initial velocity, and penetrates a fixed block of wood. In 0.02 seconds, so this is time, it decelerated constantly. So that means there's constant deceleration and stop inside the wood. Okay, so my V equals to 0 meter per second. So this is what I should be doing when I am reading the question. I'm unpacking the information. As I'm unpacking the information, I'm assigning the physics quantity or the numbers with letters or symbols. So this is very important when you're doing your calculation. Okay, so they want us to calculate the depth of penetration. Now the depth of penetration, we can say that is the distance traveled by the bullet when it hits the block of wood and how far it traveled inside. So we can actually use our VT graph. Remember, VT graph is actually very useful. We have initial velocity, we have final velocity, right? We have the time taken, right? And VT graph, what is important? If you have forgotten, firstly, the gradient represents acceleration. Okay. Secondly, the area under graph is the distance traveled. Okay, and since they're asking for the depth, which is actually the distance, we can use the area under the VT graph to calculate. Okay, so we can actually plot our graph here, and because the question says that it decelerated constantly, therefore the gradient must be constant, which means it's a straight line, and because it decelerates, so that's why it is downward sloping. Okay, so once you have changed everything to SI unit, you can actually find your displacement to be 1 meter, which is the area under the graph. Okay, they want us to calculate the deceleration. Okay, so we can use our A equals to V minus U over T. Okay, we have final velocity, which is 0, initial is 100, the time is 0.02, so we can find the deceleration to be 5,000 meter per second square. Now take note, deceleration, like what you learn in kinematics, deceleration cannot be negative. It is always a positive value, but acceleration can either be positive or negative. Positive acceleration, let's say we don't talk about change in direction. Positive acceleration means velocity increases. Negative acceleration means velocity decreases if we are not talking about change in direction. Okay, now they want us to find the average force. So this is actually how kinematics can be linked to your dynamics in your final term exam or O level, because both have the idea of or concept of acceleration. Okay, so now F net equals to ma. The question actually guided you to calculate the acceleration or deceleration. You can actually substitute in here. You have the mass. Remember, this is a SI unit formula. So this is 0.01 multiplied by 5,000, right? So you'll get 50 Newton. So actually the wood exerts a force of 50 Newton on the bullet. By Newton's third law, bullet, F bullet on wood is 50 Newton. Force of wood on bullet is also 50 Newton. Okay? So they can ask you about the Newton's third law here. Okay, question 11. A hot air balloon with a total mass of 2,200 kg. So again, as you are reading, give the numbers, the symbol, and the letters to represent the physical quantities. Okay, physics quantity. It hovers stationary. That means it's neither moving up or down. So can I say that the velocity is 0? Okay, at a certain height. A sandbag on a hot air balloon with a mass of 150 kg. So this hot air balloon has a few sandbags. Then one of the sandbag has a mass of, I put M as B, sandbag is 150 kg. It is then released off the hot air balloon. Calculate the lift of the hot air balloon when it's hovering at a stationary position. So draw your free body diagram. So if this mass is 2,200 kg, that means it's being pulled down by gravitational force by Earth with a force of 22,000 Newton, 22,000 Newton. Okay, but why doesn't it plummet to the ground? Because there is a lift force, okay, of 22,000 Newton. Now, a very common question is that, are these two forces a third law, a Newton's third law forces? The answer is no. Okay, important, because both forces are acting on the same object. Okay, they are acting on the same object. So you may argue, say, oh, both are equal in magnitude, okay, and they are opposite in direction. But this is the very simple way to tell whether the two forces are a pair of Newton's third law. Okay, basically both forces are now acting on the same object. Therefore, it is not Newton's third law. Okay, now back to this. So they want us to calculate the lift when it's at a stationary position. That means it is not moving. When it's not moving, okay, not moving up or down, that means no acceleration, right? That means no F net. Therefore, it must be equals to 22,000 Newton, right? Therefore, the resultant force up and down is equal to 0. So they want us to calculate the net force acting on the hot air balloon when the sandbag was released. Okay, so now that the mass is, because I released the sandbag, 2200 minus 150 kg will then be equals to 2050 kg. So that means now the hot air balloon has a weight of 20500 Newton. But the lift is not affected by the sandbag. It is actually due to the density of the hot air inside. So I will keep the lift force to still be 22000 Newton, right? So now if you have drawn this free body diagram successfully, you'll find that there is now a resultant force. And how do we represent resultant force? With a double arrow and not touching the object. Okay, so I will take the larger number minus the smaller number. So I will have 1500 Newton as my resultant force as compared to just now whereby there is no resultant force. Okay, since now there's a resultant force, okay, they can actually ask us to calculate the acceleration of the hot air balloon. Okay, so now F net equals to ma with my acceleration, my net force. My mass, take note, it has to be now the new mass, which is 2050, very important, right? You cannot still use the 2200. Then I can get an acceleration of 0.732. Okay, so please check your answer. Okay, last question. In figure 12, an airship with a mass of 12,000 kg, 12,000 kg. So this is the mass. It hovers stationary at a certain height. That means it's not moving, right? So when it's hovering stationary, that means F net on it is 0. So if I have the mass, I can actually calculate the weight is actually 120,000 Newton. If I take the formula, W equals to mg, where my g is on Earth and is typically used as 10 meter per second square or 10 Newton per kg. Okay, so yeah, this is just finding the weight first. Now the engine is then switched on, causing the propeller to spin and produce a forward force of 15 kilonewton. So it is 15000 Newton. Okay, assuming no air resistance, that means there are no force that is pushing the air balloon backwards. Calculate the initial acceleration, right? So they are talking about the horizontal movement and not the up and downwards motion. Okay, so there is a F net of 15,000 Newton. Okay, so if I have F net, then I will have acceleration. Okay, that means I can actually use the formula F net equals to ma, and because my F net is 15,000, my mass is 12000, so I can find my acceleration to be 1.25 meter per second square. Okay, so this is a very important note. Always draw a free body diagram. It will help you to visualize whether there is any F net or not. Eventually, the airship reaches a constant horizontal velocity. So again, this is a very important sentence, because constant horizontal velocity means the horizontal acceleration is 0. That means there's no F net in the horizontal direction. The F net is 0. Okay, so although the force F remains constant, what is this force F? The force F is this forward force of 15,000 Newton, right? So because there is now a air resistance, and because the F net is 0, and the forward force is 15,000, therefore the air resistance must also be 15,000 Newton. Okay, so why did air resistance increase? Because initially we take it that assuming no air resistance. So when the object is not moving, there is no air resistance. Air resistance happens because you push against air, Newton's third law, air pushes back against you. Okay, now since the airship is pushing the air, right, as it moves forward, the air will be pushing the balloon backwards. And air resistance actually is determined by a few factors. So air resistance increases when the speed increases. Okay, this was actually covered before, or the area, the contact area increases. Okay, but since the airship remains the same shape, right, then it is due to the increase in speed. Why was there an increase in speed? Because in part A there was an acceleration. Okay, so air resistance is also it can be due to the density of air increasing, but since they didn't mention anything about that, the only reason why there is more air resistance is because the speed increases, and speed increases because there is acceleration. Okay, so now the airship was traveling at a constant horizontal velocity. So again, this is important, no Fnet. So this was the horizontal velocity of 20 meters per second when the engine was switched into reverse. So that means I can put this 20 meters per second as my initial velocity, right? So now the engine switched into reverse. So in 10 seconds, the airship decelerated constantly, like our previous question, one of it, to a stop, ignoring the effects of air resistance. So now we don't care, right? We don't need to care about the air resistance. Calculate the average force acting on the airship. Okay, so in 10 seconds it decelerate constantly to a stop. I miss out this stop. Stop means my final velocity is 0, and 10 seconds is our t. So again, I can calculate my acceleration or deceleration. So final is 0, initial is 20 over a period of 10 seconds. So I'll get minus 2.0 meter per second square. Okay, so now there is actually a deceleration of 2 meter per second square, right? So therefore my Fnet is equals to MA. The mass is 12000 multiplied by this 2, I will get 24,000 newtons. That means the reverse force is 24,000 newton because the question asks us to assume no air resistance. So if I were to look at the free body diagram, there should only be a horizontal force of F, which is when the engine was switched into reverse. Okay, so they didn't tell us that the engine force is always constant. It can be higher, it can be lower, and in this case it is actually higher than the forward force that it exerts just now. Just now was 15,000. Okay, so now they use a larger reverse force in the opposite direction to stop the airship. Now calculate the displacement of the airship after the engine was switched into reverse. So again, we rely on our VT graph because this one we can calculate the distance, which is area under the graph under VT graph. Okay, so that's why we teach kinematics first. They have the idea of acceleration, and our dynamics, we also have the idea of acceleration. So you should be able to get 100 meters, and because they told us that it is a constant deceleration, that's why you can draw it to be a constant negative straight line.